All right, welcome to The Explainer. Today we're going to talk about something you hear every single day, but probably don't think too much about: the science behind broadcast audio. We're going to figure out exactly why the sound coming from your TV can be, well, all over the place. So let's just jump right into it with a problem I know everyone has dealt with. Picture this: you're kicked back watching a super quiet, tense scene in a movie, and then boom, a commercial just blasts through your speakers, sounding about a million times louder. You start wondering, what is going on? Is my TV busted? Well, nope, it's actually happening by design, or at least it used to. And we're going to find out exactly why. Okay, so to really crack this volume mystery, we've got to go back to basics. We need to talk about what sound is, fundamentally. It's actually this incredible journey from just a physical thing happening all the way to a sensation that we feel inside our heads. So, at its core, sound is really just a vibration. I mean, think about it like a domino effect. Someone plucks a guitar string, right? That string vibrates and it pushes the air molecules around it. A microphone then hears that push and turns it into an electrical signal. And then, way at the other end, your speaker takes that signal and vibrates in the exact same way to make the sound all over again for you to hear. Literally every sound you can imagine is made up of these three basic ingredients. You've got frequency, which is just pitch, the difference between a deep bass note and a high squeak. Then there's amplitude. That's the easy one. It's just loudness, the sheer power of the sound. And finally, you have timbre, which is kind of the magic ingredient. It's the quality of the sound. The reason a guitar and a piano sound totally different, even if they're playing the exact same note. And when we talk about that power, that amplitude, we measure it in something called decibels. This chart gives you a pretty good idea of the range we're talking about. A whisper is super quiet, down around 30 decibels. Our normal talking voice, like mine right now, is probably hanging out around 60. And then you get to loud music or a concert, and you're easily pushing past 100 decibels. But a speaker making a noise is only half the equation. The other half is this amazing piece of biological tech we all have: our ears. They're like these super advanced microphones. Sound waves go in, they make your eardrum vibrate, and then these tiny little bones pass that vibration along until it gets turned into electrical signals. But here's the crazy part. It's your brain that does all the heavy lifting. It takes those raw signals and translates them into everything we recognize as sound. All right, so that's the physics and the biology. Now let's talk about the tech, because how we deliver sound has evolved like crazy. We've gone from just a single, lonely speaker to building entire sonic universes right in our own homes. For the longest time, everything was in mono. That means all the sound, every line of dialogue, every note of music, got shoved into one single channel. It just came from a point. But the jump to stereo? Whoa, that was a total game changer. Suddenly you had a left and a right channel. Sound could move. It had space, direction. It felt so much more real, way more immersive. And of course, today we've taken that idea and just run with it. Surround sound is way more than just left and right. The really clever bit is that center channel. It's dedicated almost entirely to dialogue, so you can always hear what people are saying clearly. Then you've got your surround speakers behind you, pulling you right into the middle of the world with ambient sounds. And of course, the subwoofer. For that bass, you feel more than you hear. Okay, so we have all this amazing tech. But how does the sound actually get from, say, a movie set or a studio all the way through the airwaves and into your speakers at home? Well, it's a pretty precise journey. It really is a chain. It starts with a microphone capturing the raw sound. Then an audio engineer sits at a massive mixing board and balances all the different parts: the voices, the music, the explosions. After that, they apply all sorts of processing. We're talking EQ and compression to polish it up and make it sound great. And only after all that does it get sent out, picked up and decoded by your TV, and finally pushed out of your speakers. All right, here we go. We are now at the absolute heart of the matter. To finally understand that whole loud commercial thing, we have to look at how broadcasters used to measure volume. And it all boils down to one very technical and slightly flawed standard. For a long time, the industry standard was something called dBFS, which stands for decibels full scale. Think of it like this. In digital audio, there's a ceiling, an absolute maximum volume that the system can handle. That ceiling is called 0 dBFS. You cannot go above it. If you try, even by a little bit, you get this awful, crackly distortion called clipping. So this is the key thing to get. Audio engineers are always working down from that ceiling. That's why all their measurements are in negative numbers. They're not measuring how loud something is, they're measuring how far below the maximum it is. So, a pretty standard level for a show might be around minus 12 dBFS, with the loudest parts maybe hitting minus 6, just to leave a safe amount of headroom before you hit that dangerous zero. And right here, this is the fatal flaw in the old system. You can have a TV show and a commercial that both have the exact same peak level. On the meter, they look identical. But does that mean they sound the same to our ears? We all know the answer to that, don't we? It's a huge, emphatic no. So, that massive difference between what the meters said and what we actually heard forced a revolution in the industry. People realized they needed a totally new way to measure volume, one that wasn't based on technical peaks, but on, well, on how humans actually hear. And that's where LKFS comes in. Seriously, this was a game changer. LKFS is a much smarter standard. It uses a clever algorithm that's designed to listen more like a human ear does over time. It doesn't really care about quick, sudden peaks, like a single gunshot. It cares about the average sustained loudness. In other words, it measures the experience of loudness, not just the raw signal. So if you take away one thing, let it be this. DBFS, that's for the machines. It's a technical tool just to make sure the signal doesn't break. But LKFS, that's for us. It's for humans. It measures what we actually perceive as loud, which is what really matters when you're just trying to watch TV in peace. And this right here, this is the magic number that saved our ears. Pretty much all major broadcast standards around the world now say the same thing. Everything, the movie, the ads, the news, it all has to average out to negative 23 LKFS. No exceptions. And that one rule is what creates consistency from one program to the next. Okay, let's tie this all together. Let's finally answer that first question and figure out what all this means for you sitting at home with the remote in your hand. So here's the big reveal. Back in the day, a movie would have quiet bits and loud bits, right? But the commercials, their audio was heavily compressed. Think of it like squashing the sound, making all the quiet parts loud and the loud parts still loud. They filled up every last bit of space right up to that technical 0 dBFS ceiling. So even if the peak was the same as the movie, the average was way, way higher, which is why it sounded so jarring. The new LKFS standard makes that trick impossible. Now the ad's average has to be the same as the show's average, period. And really, that quote says it all. The whole philosophy has shifted. It's not about a loudness war anymore. The goal of good broadcast audio today is about delivering an experience that's crystal clear, super consistent, and just comfortable. It's about letting you put that remote down and not have to worry about it. So the next time you're watching TV and you realize you haven't touched the volume control in an hour, now you'll know why. It's all thanks to this brilliant bit of audio science that finally started measuring sound the way we actually hear it. So now that you know the difference between a technical volume and perceived loudness, the question is, will you start to listen differently? Thanks for watching this explainer, and for more such valuable information, please subscribe to our channel.